Hello everyone, I am Professor Vaibhav Shah. Welcome to yet another lecture on engineering curves. Today we are going to learn how to draw an involute of a circle. There are many types of involutes possible depending on the shape of an object. Involute of a circle, involute of an arc, involute of a square, involute of a pentagon, involute of a hexagon, and so on. In subsequent lectures, we will be learning each of these types one by one. If you like my content and teaching style, then do not forget to like and subscribe to show your love and support. And try to share it with your friends, which might help them to clear their concepts. Let us start with one of the problems. Problem 1. Draw involute of a circle of diameter 50 mm. String length is equal to the circumference of a circle. So here we are learning the first condition in which length of string is exactly equal to the circumference of circle. So circumference of circle is nothing but 2 pi r, or you can say pi d. So here we have one circle and we have to draw an involute of a circle in which we have the string length exactly equal to the circumference of the circle. So now let us start with the procedure. So first of all, we must draw one circle with the given diameter. So take out your rounder, then draw one circle with diameter is equal to 50 mm or radius is equal to 25 mm. Now, after drawing this circle, we will divide this circle into 8 number of equal parts. How you will divide into 8 number of equal parts? It is very simple. Either you can draw each part at 45 degrees or you can use 45 set square to divide this circle into 8 number of equal parts. Now, after dividing this circle into 8 number of equal parts, we will first calculate the required length of string, which will be of the length of circumference of the circle. So once again, what is the equation of circumference of the circle? So here, the length of the string will be exactly equal to the circumference of the circle. So circumference of the circle is nothing but 2 pi r, or you can say pi d. Now, always remember, in this example, we are assuming that we are winding the string over this circle. So we'll be winding this string over this circle completely for one rotation, which will give us involute of a circle in this case. So let us first find out the required length of string. So let us see, required length of string is equal to pi d, or you can say 2 pi r. So here the diameter d is given, which is nothing but 50 mm. So we have to just substitute the 50 mm in place of this d. So we'll be having pi into 50, which will give us the required length of string, which is nothing but 157.08 mm. So this is the total length of string required to be wound around this given circle. So now let us draw one string tangent to this circle from the bottom portion of this circle. So this is a string. Now, always remember, here we are winding the string. So we are winding the string. That's why the numbering pattern would be very specific. If you write wrong numbering pattern, then you will lose marks. So now let us see how to give numbering to this circle. So now the point from which this string is connected to the circle is always called as 0 or initial point. So let us denote this point as 0 point. Now we will give numbering in anti-clockwise direction. Now let us understand the logic why I have given the numbering in anti-clockwise pattern only. So whenever it is said you are winding the string that means your numbering would be of this type. So let us understand. So now this is our string. If I try to wind this string, so it will just wound around this circle like this. String will just wound around this point. So let us understand, string will first touch to this point on this circle. So whichever point string will touch on this circle first from these 8 given parts will be the point number 1. So always remember, whenever the string touches any part, so the string will first touch this part while winding operation. If you try to wind the string around this circle, so string will first get in contact with this part 1. That means this is always called as point number 1. If this is point number 0 as a starting point, and if this is point number 1, then we have to give obviously the numbering in anti-clockwise direction. So let us give numbering 2, 3, 4, 5, 6, 7, and 8. Understood? Okay. Now, we have divided this winding operation into 8 parts of the circle's circumference. That means your string will wound round this circle also into 8 number of equal parts. But that's why we have to also divide this length of string into 8 number of equal parts. So let us divide this length of string into 8 number of equal parts. So we have divided this length of string also into 8 number of equal parts. Now it is the time to give numbering to this string. So it is obvious that this string is connected to this circle by this point. That means this point will denote point number 0. So this will be 0, this will be 1, 2, 3, 4, 5, 6, 7, and 8. So point P would be your final point, point number 8. So let us give numbering 1, 2, 3, 4, 5, 6, 7, and 8. Now next step. So here it is said that your string is wound around the circle. That means you are holding the string from your point number P, and you will try to rotate it around the circle. At the time of rotation, the portion of string will get attached to this circle and will start winding over the circle. And finally, when the string is completely turned by 360 degree around the circle, string will be completely wound over this circle. So now at any particular position, as you can see, this is your 0 position. Your string is at 90 degree to this position, or you can say string is tangent at 0 point. So whenever your string will be at point number 1, it will be obviously tangent to that point number 1, or you can say, in other words, it would be 90 degree to this point number 1 line. Now whenever your string would be at point number 2, at that time your string would be tangent to that point number 2, or it would be at the 90 degree to this point number 2. Likewise, whenever your string would be at point number 3, then at that time string would be tangent at point number 3, or it would be at 90 degree to this point number 3. So in short, we have to draw from each of these points 1 to 8 tangent lines. So let us start plotting tangent lines from these point 1, 2, 3, 4, 5, 6, 7, and 8. 8 line is already drawn. Now we will start our procedure to winding this string around this circle. So let us understand, when I try to hold this point P and try to rotate in anti-clockwise direction, the portion showing partition from A to 1 will try to wound around this circle like this. So this portion would be now in contact with the circle, and it will be completely wound around this circle. So when I move this point P in anti-clockwise direction, the first portion which will wound around this circle would be the portion of A to 1, or you can say 0 to 1. So you can see this point 1 would come here over this point 1. So it will superimpose this circle at point number 1. So now the portion of the string wound around the circle would be of this length. So this is your length of string which is utilized over the circle. Now, which is the portion of string left over? So this is the portion starting from your point number 1 till your point number 8 would be the portion from this point 1 till this point 8. So we'll be having the extra additional length of string which is still to be wound. It is from point number 1 till point number 8. Now let us locate this point. So this is point 1 to P, or you can say 1 to 8, because 8 and P are both the same point. So what you will do is you will take out your rounder, put your rounder at point number 1, take the radius is equal to 1 to 8, and now put your rounder at point number 1 and try to mark this radius on this similar line, which will give the distance between point 1 to 8 or point 1 to P. So this will be your final point P1, which is nothing but the first position of your string when wound around this circle. Now, when we try to wound this string around this second number point, so your string from starting point 0 or A till the length of point 2 will be overlapped around this circle like this. So now your point division from 0 to 1 and from 1 to 2 will be wound around like this on the circle. So 0, 1 and 2. So your total string utilized over the circle is 0 till 1 to 2. So your total string wound around this circle would be 0, 1 and 2. So now the remaining length of string would be 2 till 8 or point P. So now once again take out your rounder, put your rounder at point number 2, take the distance equal to point 2 till point P. Now put your rounder at point number 2 on this circle and locate this distance on this line. You will be having this as point number P2, which is the distance from 2 to P. Similarly, when we try to wound this line once again, so now we will be winding from 0 to 3 on this circle. So now total divisions which will be overlapped over the circle would be 0 to 1, 1 to 2 and 2 to 3. So 0 to 1 here, 1 to 2 and 2 to 3 would get overlapped or wound around this circle. So the remaining string length would be point 3 till point P. So now for this step, take out your rounder once again, put your rounder at point number 3, take the distance from 3 to point P. Now put your rounder on the point 3 on this circle and try to cut this line. You will be having this point P3, which is the distance from point 3 to P. So as you can notice the pattern, when we are at the point 1, we are using the radius from 1 till P to obtain this point P1. When we are at point number P2 or 2, we are using radius from starting from point number 2 till P, 2 to P. When we are at point number 3, we are using radius 3 to P. So similarly, when we are at point number 4, we will be using radius 4 to P on your rounder. We will be having this line and point P4. Similarly, when we are at point 5, we will be using radius from point 5 till P on our rounder. We will put our rounder at point number 5. We will try to cut this line. We will be having point number 5. Likewise, you will take the distance of 6 to P on your rounder and you will get this P6 point on your 6th line. Similarly, you will take the distance from 7 to 8. You will put your rounder at point 7 and try to locate this point 8. You will be, P7. This will be your point from your 7. And now, finally, this smaller portion of string would completely wound around the circle, which will completely overlap this circle now. So the final point would be at point number 8. So you have to take on your rounder point 8 till 8 distance. As you can see, point 8 itself a point P. So that's why our radius would be 0. That means our radius would be a point view here as point number 8. So let us denote this as point number 8. So this is our final point. Now, next and final step in which we'll start joining this line. So you have to always remember, you will start your joining your line from your starting point, which is P or P0 point. Then after P1, P2, P3, P4, P5, P6 and like that. So you will be using your freehand drawing to join all of these points. So let us start joining this point like this. So you will be using freehand drawing to join this point. After getting this curve, when you are sure your curve is correct, then you will make it dark. Then it is your final drawing, which is nothing but the involute of a circle. So this red generated curve is your involute of a circle, and it is generated around the circle. That's why it is known as involute of a circle. Now let us see one more example for better understanding. Problem 2. Draw involute of a circle of 30 mm diameter. Also draw tangent and normal to it at any point. So here we have to once again draw involute of a circle. Here the diameter given is 30 mm, and we have to draw tangent and normal. So tangent and normal we'll look after the example is over. So now let us begin. So once again we are assuming that here we are winding the string. So we are taking winding of string as our condition. Second, here the length of string would be once again exactly equal to your circumferential length of your circle, which is nothing but 2 pi r, or you can say pi d. So now let us calculate the required length of string to completely wound around this given circle. So now required length of string equal to pi d. Here diameter d is given as 30 mm. So let us put 30 mm. So we'll be having 94.25 mm. So now this is the length of the string that you have to use for this example. So now let us begin. So first of all, we have to draw one circle with the given diameter, which is nothing but diameter 30 mm. So this is the symbol of diameter, which is known as phi. So phi 30 means diameter of the circle is 30 mm. So we have drawn this circle with 30 mm as a diameter. After drawing this circle, we must divide the circle either into 8 number of equal parts or 12 number of equal parts. If you are dividing the circle into 8 number of equal parts, you will be using 45 degrees set square. Or if you are dividing the circle into 12 number of equal parts, as in this case, we are using 30 degrees, 60 degrees set square, or simply you can say each of the divisions are 30 degree apart. So now let us divide this circle into 12 number of equal parts. After dividing this circle into 12 number of equal parts, you have to draw the length of the string from the bottommost part of the circle, from this point. So now from this point we'll be drawing the length of the string exactly equal to pi d. So here our pi d distance is nothing but your 94.25 mm. So now we have to draw one line, horizontal line of 94.25 mm. After drawing this line, we will give first numbering to this circle, and later on we will give the numbering to this line. So now let us give numbering to the circle first. So always remember, whenever this string is connected to the circle, this point is known as point of origin or initial point, which is always denoted by 0. So here we will specify this point as a 0. Now when we try to wound round this string rotating in anti-clockwise direction, first the portion of the string which will be getting in contact with the circle would be this portion from 0 till 1 dash, which will come in contact with this point number 1. So string first will get in contact with this point number 1. That means this partition is obviously known as point 1, because string will get in contact with this point first. So that's why we have given this point as point number 1. Now if this is 0, this is 1, then it is obvious that we have to give the numbering in anti-clockwise pattern. So let us give numbering 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this point would be finally your point number 12, which is also known as here as point P. So now we have divided this circle into 12 number of equal parts. Now we remember that this length of string is also exactly equal to the circumference of the circle's length pi d, that means if we are dividing this circumference of this circle into 12 number of equal parts, then it must be that you have to divide this line also into 12 number of equal parts, because it is the length exactly equal to the circumference of the circle. So let us divide this straight line also into 12 number of equal parts. So we'll always start from 0 because this is the initial point. 0, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and P dash, or you can say 12 dash. Now next, likewise from the previous example we know we are drawing from each of these points one tangent line or line perpendicular to this partition. So from point P1, from point 1 we'll be drawing line perpendicular to this line like this, or you can say you will be drawing tangent from your point number 1. From point number 2 you will be drawing line 90 degree to this line like this, or either you can say you will be drawing tangent at point number 2. Similarly, you have to draw line 90 degree to this line from point number 3, or you can say you have to draw tangent from point number 3. Likewise, from point number 4 you will be drawing tangent, from point 5, from point 6, from point 7, from point 8, from point 9, from point 10, from point 11, and from point 12. Now 12 is your last point, or you can say it will be the point on this circle. So we need not to draw any tangent for this point number 12 or point P. So now we have drawn tangents from each of the points just like our previous example. Now next step. So first of all, when we try to wound the string around this circle, so portion of 0 to 1 dash will first get in the contact with this 0 to 1 portion. So the portion of 0 to 1 dash will get wound over this circle. So your string utilized is from 0 to 1 dash. So now you will be having additional length of string which is left. So 1 dash till P dash is the string which is left for the next operation. So from point 1 you will be having one extra string which is left after this point 1. So this is nothing but the length of string from your 1 dash till P dash. So now we'll be using our rounder. So put your rounder at point number 1 dash. Take radius equal to 1 dash till P dash. After that, put your rounder at point number 1 on this circle and try to cut this line. You will be having this point as your P1 point. Now, when we try to wound this string around this circle, now from point 0 till point 2, at that time we will utilize the string 0 till 2 dash over this circle. So now 0 till 2 dash will overlap this circle like this. So we'll be left with the string 2 dash till P dash. So now take out your rounder, put your rounder at 2 dash and take the dimension from 2 dash till P dash. Now with this dimension, put your rounder at point 2 and try to cut this tangent line of this 2 to get your point P2. From point 3, similarly, you have to put your rounder at 3 dash and take the dimension from 3 dash till P dash. And now put your rounder at point 3 on this circle and try to draw or cut this line of 3 here. You will be having this point P3. For point P4, you will be taking distance from 4 dash till P dash. Now you have to put your rounder at point 4 and you have to cut this line to get this point P4. Similarly, for point 5, we'll be taking dimension of 5 dash till P dash from this line. You have to put this dimension over this tangent line of 5. You will be having this P5 point. Likewise, you have to get this point P6, P7, P8, P9, P10, P11, and 12th point or final point would be the overlapping point over the circle. This will be your point P, or you can say P12. So after getting all these points, it is very simple. You have to simply connect all these points starting from this P dash point, P dash, P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, and P12 or P point would be the final point on the circumference, which shows that your string length is gradually winding over this circle. So you can see this is nothing but your string length. So you can see this is gradual reduction of this string length. This is also reduction. And likewise your string gets reduced in the length. So this is your string length. This is your string length. So it is getting wound around this circle. This is a string length. This is your final string. And when you try to wound this string over, so this portion of string would be here over the circle. So now your complete string is wound around this circle. So this is nothing but your involute of a circle for this case. Very easy. Now, let us look for this tangent and normal to this curve at any point. So we have to draw tangent normal to this curve. So this is our curve which is known as involute of a circle. So we will be drawing tangent normal at any point. So let us select any point M here. So you can select any point randomly over the curve. You can select here or here. It's your choice. Wherever you want to select point, you can select. So I have selected point M somewhere here between P4 and P5. Now, after selecting this point on this curve, you have to simply connect this point till the center point or the pole of this circle. So we'll be joining this point M with the straight line with your scale to your center point O. Now, after joining this point to your center point O, we will then find out the midpoint of this line MO. So you have to find out the midpoint of this line M and O. So let us suppose this is the midpoint of this line. Now we have found out the midpoint, which will be nothing but your center for your semicircle. So now we have found out this midpoint. Now you will ask, sir, how to find this midpoint? So either you can say or use bisection of the line method to find out the midpoint of the line, or you can directly put the value in your calculator and you can have the midpoint. But remember that you have to accurately mark this midpoint. If your midpoint is wrong, then you will have a incorrect tangent and normal. So you have to mark this midpoint somewhere here, joining this line M and O. After getting this midpoint, next task is very simple. Taking that point as a center and from that point till point M as a radius, you will draw one semicircle. But wait, there are two possibilities. If this point is your circle, then you can either draw the semicircle on the left hand side like this, or you have the possibility to draw your semicircle on the right hand side of the line like this. So now you will ask, sir, how can we decide on which side you have to draw a semicircle? Either we can draw on the left hand side or you can draw on the right hand side. So now let us understand the logic on which side you will draw your semicircle. And always you have to follow the logic, else your tangent normal would be completely wrong. So now let us see. Let us observe. Now our point, selected point M is in between point number P4 and P5, right? Okay. So now we'll take our rounder and we'll put at the center. Now let us just try to visualize if we try to draw the semicircle on this left hand side portion. So let us see, we are drawing the semicircle, suppose on the left hand side of the portion. So it is possible that the semicircle will pass between 9 and 10 point of this circle. Semicircle will pass between the 9 and 10 point of the circle if we draw semicircle on the left hand side of this line MO. Now if we try to draw the semicircle on the right hand side of the circle like I have drawn in this example, on the right hand side of the circle, so you can observe that our semicircle is passing between the point 4 and 5 on this circle. You can see his semicircle is passing between point 4 and 5 on this circle. So logic is very clear. Our selected point here, point M, is in between point P4 and P5, which suggests that whenever you are drawing this semicircle, it must pass through point 4 and 5 of this circle here. If you have drawn your semicircle on the left hand side of this line MO like this, then your semicircle would pass between point 9 and 10 here like this, from between 9 and 10, then there are chances your tangent normal would be incorrect. So always remember you have to draw the semicircle in such a way that it must also pass between this point 4 and 5 of this circle like this. So now we have drawn our semicircle on the right hand side of this MO line from our center point of this line MO. After getting this semicircle drawn, this semicircle will intersect this circle somewhere here between 4 and 5. So mark this point as point N, which is a first normal point, and connect this point N to this point M and extend this line. Then you will be having this line which is N dash N line, which will denote you the normal. And the line drawn 90 degree to this normal is known as tangent. Very simple. So let us see one more example. Problem 3. Draw involute of a circle of 60 mm diameter. Also draw tangent and normal at any point on the curve. So this is just similar to the problem number 2. So you can also try it by yourself. So now let us start the example. So our assumptions are same. We are taking winding of string. So we'll be winding around this string over this circle. Second, here the length of the string would be exactly equal to the circumferential length of your circle, which is nothing but 2 pi r, or you can say pi d. So now let us first of all find out the required length of string, which is equal to pi d. Here the diameter is given as 60 mm. So we'll be having 188.5 mm the length of your string. So first of all, we will try to draw one circle with a diameter 60 mm. We can denote it by 560. After drawing this circle, you will draw the string length of pi d from the bottom portion of this circle tangent to that circle. After drawing that, we have to give numbering. So it is obvious that the connection point of the string with the circle will be the initial point. We will be denoting this point as point 0, and from this point we have to give numbering. So now in this winding operation, this portion 1 dash will first get in contact with this point 1. So that's why our string will get in contact with this portion first. That's why we have denoted this part as point number 1. So if this is 0, if this is 1, then it is obvious that our notation pattern would be anti-clockwise pattern. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, or either you can say point P. Now let us give numbering to this line. So first of all, we have divided this circle into 12 number of equal parts. That guarantees that you must divide this straight line also of your circumferential length pi d into 12 number of equal parts. After dividing this line into 12 number of equal parts, we will be giving numbering. So starting from this point as 0, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and final point would be 12 dash, or you can say P dash. After that, similarly, we have to draw tangents from each and every point. So from 1, tangent, 2, tangent, 3, tangent, 4, tangent, 5, tangent, from 6, tangent, 7, tangent. Now, how will you draw tangent? So you have to just draw line 90 degree to this line. This is your line. You have to just draw 90 degree to this line. You will be having this tangent. From 9 tangent, from 10 tangent, 11 tangent, and 12th point would be the point on your circle or your point number P itself. After that, let us start the procedure. So in first stage, the portion of 0 till 1 dash will overlap over this circle or will wound round the circle. So we'll be having remaining string length of 1 dash till P dash. So for that, you have to take out your rounder, put your rounder at point 1 dash and take the dimension of 1 dash till P dash on your rounder. Put your rounder at point number 1 on this circle and try to cut this line. You will be having point P1. For point number 2, our string would wound round from point 0 till 2 dash over this point 0, 1 and 2 like this. 0 to 1 will wound round around 0 to 1. 0 to 2 dash to 2 dash will wound round on this point 2. So we will be having remaining string length of 2 dash till P dash. So take on your rounder length starting from your 2 dash till P dash. Now put your rounder at point 2 on the circle and try to cut this dimension of 2 dash till P dash here. You will have this point P2. Similarly, take the dimension of 3 dash till P dash from your straight line and put your rounder here to mark this point P3. Similarly, take the dimension of 4 dash till P dash, put your round at point 4, mark this point P4 on this line 4. Take the dimension of P5 till 5 dash till P dash, put your round at point P5 and try to get this point P5. Similarly, get P6, P7, P8, P9, P10, P11 and P12 or point P would be the point on circle itself. This is the point. After getting all these points, you have to start joining the procedure from this point P0 or P dash like this: P dash, P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11 and point P. So this is nothing but your involute of a circle. Now let us see how to draw tangent and normal. So in this case, it is said that you have to draw tangent normal at any point. So let us suppose in this example, we have selected this point M here. So this is the point we have selected between point P2 and P3. And we have to draw tangent and normal at this point M. So first of all, connect this point M with your center point like this. We have connected this point M with the center point. After that, you have to find out the center point of this CM line. You have to find out the center point of CM line either by your bisection method or you can find out by calculator. So you will be finding out the center point line. After that, you have to draw the semicircle. In this case, you can draw semicircle on the left hand side of this line, CM line, or either you can draw semicircle on the right hand side of this line, CM. So now here I have drawn semicircle on the right hand side of the CM line. Why? Because here our point M, selected point M, is in between point P2 and P3. That suggests that our semicircle must pass through point 3 and 2 on this circle also. So we have drawn our semicircle in the right hand side direction, so which is passing between your point 3 and 2, and it will give us this point Q. So you have to just connect this point Q till M, and you have to extend this line. So you will be having this NQ, which is nothing but your normal, and you have to draw a line 90 degree to this normal. You will be having TT dash, which is nothing but your tangent, which is 90 degree to your normal. So once again, how to draw this semicircle? So you have to connect this center with your selected point at where you have to draw the tangent and normal. So I have connected M with the C. After that, you have to find out the center point of CM, and after that you have to see or check whether to draw your semicircle on the left hand side or right hand side. Now we have drawn on the right hand side because our point selector point M is in between P2 and P3. That suggests that our point semicircle point must pass through between 3 and 2. And after that, the procedure is very simple. So this is all from my side. If you enjoyed my lecture, then do not forget to like and subscribe to show your love and support. Keep learning, stay connected. Bye-bye.